Projectile motion. We'll now do a few projectile motion problems without numbers, and we want to see if your physics intuition will help here. And we're also going to back it up by going back to the equations we use to give us exact numbers. So we're going to use conservation of total mechanical energy and kinematics. We're going to start, and all of these will start the same. We have four objects, A, B, C, and D. We're going to do different things with them. Well, actually, they're each going to get thrown off with the same velocity, and then find out what happens to them. So again, each one has the same magnitude of velocity, and we use magnitude because clearly this is a negative velocity and this is a positive, but we're going to talk about magnitudes here. First question, which object will have the greatest magnitude of velocity right before it strikes the ground? If you haven't thought about the answer, please backtrack because we're going to give you the answer on this slide here. We know that each object starts with the same energy. They are at the same height, right over here, so they all have the same gravitational potential energy. And since they all have the same magnitude of velocity, they have the same kinetic energy. But we don't worry about the directions here, which way they're shot, right? Because when you use conservation of energy, we just worry about the initial position and the final position. And they're all going to land at the bottom. So each object reaches the ground with the same gravitational potential energy, which is 0. And since total mechanical energy is conserved, they have the same kinetic energy. Hence, they have the same magnitude of velocity. The answer is E.